Hello, my name is Taiwo Banle Olayiwola, and the topic for this undergraduate research will be studying the microstructure variation in additive manufactured parts. This project was conducted under the supervision of Dr. Narges Shayesteh under the Mechanical and Aerospace Engineering Department. To gain insight, additive manufacturing has emerged as an upcoming technology which offers unique ability to fabricate complex parts for high-end applications. Some major disadvantages that this proposes are the formation of defects and the generation of residual stresses due to variation of the temperature gradient during the process. To eliminate these defects, post-process heat treatment can be performed to the specimens, which make this process costly. Microstructure analysis is a widely used method to review the possible defects of alloys. Through analyzing the microstructural properties, it is possible to evaluate the quality of a part and optimize the process parameters. The objective of this research is to investigate the variation of the microstructural properties in a manufactured part and propose applicable solutions to eliminate the defects and improve the quality of the part. One critical issue with additive manufactured specimens is the inconsistency of texture and microstructure. It has been reported that the grains are finer in the regions close to the substrate due to the associated higher cooling rate. This presents a problem to the uniformity desired by this process. Another major issue is the presence of defects within additive manufactured parts due to variation of the temperature gradient during this process. Some commonly observed defect types in this process are surface defects, which include porosities and cracks, particularly near the substrate, as seen in Figure 1. To the left, we can see some cracks in the parts, and to the right, we see some inconsistencies in the surface due to trap powders. The selective laser melting process is good for components with great geometric complexity, such as internal cavities and grids. This is ideal for parts with low volume and high quality requirements. For this study, in order to produce SLM nickel titanium parts, a laser power of 250 watts with a scanning speed of 1.25 millimeters per second and a hatch spacing of 120 micrometers have been used to melt each layer of nickel titanium powders with 30 micrometer thickness. Dense rectangular 12 by 6 by 6 millimeter samples were fabricated after 400 layers of printing. A flow diagram of the microstructure analysis process is shown in Figure 3, with the start including a part removal and then being moved through to a cutting procedure to meet dimension requirements. It is then later moved to a polishing and grinding step to obtain uniformity in the part. After this is completed, it is moved through etching with protective layers and then is finally passed through for the SEM analysis on a scanning electron microscope to generate the image of the sample on a micro level. For the experimental results, in the region near the surface, smaller grain sizes were observed with aqueous structure. It is clear that the grain size increases gradually as the focus moves towards the center of the specimen as seen in Figure 4. Figure 4 is a top view of the grain structure, with part A being near the surface and B being away from the surface. Crack formation can be observed in the top view from the area near the edges of the sample that derive from different origins. Rough surfaces as well as small cracks can also be found in the area near the surface displayed in Figure 5. In conclusion, a scanning electron microscope provides a high spatial resolution that provides microscopic level surface quality and helps reveal structural defects in a sample. These microstructural defects are important to obtain for analysis about the sample's material properties so they can be investigated. With using different inspection methods, the quality of additively manufactured parts can be used for additive manufacturing research purposes. A microstructure consisting of larger grains were found in the top view near the boundary of the surface, while rough surfaces as well as small cracks were found in the area near the surface displayed.